On to this webinar hosted by Toradex entitled Mixed-Criticality in Safety Critical Avionics and Defense Communications with NXP i.MX 95 and SYSGO PikeOS. The topic of today is about aerospace and defense applications demand. So these applications are actually very demanding in terms of rapid iteration and uncompromising safety. So in this joint webinar with our partner SYSGO, we'll be showing you how to achieve both, basically iteration, like a rapid iteration, and this safety on the new i.MX 95-based Toradex modules. So we have great content for you today. So my name is Carlos Gonzalez. I am the head of partnerships at Toradex. And with me, I also have Stefan Wagner, who is research and technology engineer at SYSGO, which is a Toradex partner. With this, let's get started. Let's have a quick look at the agenda for today. First of all, we're going to have a look at Toradex in a nutshell. So what are our credentials in the aerospace and defense sectors? Then I will hand it over to Stefan to demonstrate how PikeOS offers very strict partitioning, deterministic performance, and a very clear path to relevant industry certifications. Then we'll look at the i.MX 95 platform, which is now supported by PikeOS, and we'll look at the specifications, and then we'll look at all the different families and the roadmap. And finally, we'll just look at what is the value that we are bringing to customers together with SYSGO. Let me just get started with Toradex. As you may know already, we are a Swiss-based embedded computing company. We offer ARM system of modules, which are basically known for their reliability and the long-term maintenance. So we, for example, have a very wide temperature range from -40 to +85 degrees Celsius. In addition to SOMs, we also have carrier boards, which are off-the-shelf carrier boards that you can actually use for development and also for production purposes. And we provide the design files for these carrier boards in case you want to customize them. Also, we have the ability to tailor these carrier boards, essentially produce end products. We have a new division for volume manufacturing, so we can actually take care of the whole product lifecycle for you, even producing enclosures, connect peripherals, and essentially complete end products. But actually, one of the main reasons why customers choose Toradex is because of the software support. So we support operating systems off the shelf. Essentially, you have ready images like Yocto-based BSPs, but we also have our own embedded Linux distribution, Torizon OS. Then on top of that, we have this IoT platform called Torizon Cloud. So we'll get into that a bit more. But I think the key thing here is that we support as well third-party operating systems like PikeOS, which are very relevant for this specific use case that we'll be talking about today. Also important to point out is that although we have Swiss roots, we are a global organization which has manufacturing in Europe, also in Asia and America. We enable customers to comply with avionics and defense requirements, including the International Traffic in Arms Regulations, ITAR, which is US legislation that controls the export and import of defense-related products. So started already, we have actually manufacturing in America for customers that wish to have that ability. So why are we working with SYSGO? So we actually started working with them over a year ago to bring the power of PikeOS to the NXP i.MX platform, starting with an i.MX 95. And with this collaboration, we want to enable customers to use the same hardware for two life cycles, essentially. So we want them to prototype very quickly, maybe actually starting with Linux, and then lock partitions and certify using the same code. So essentially allowing them not to reinvent the wheel when they have to go through certification. The good thing of using the system of module platform that we have is it speeds up your time to market, and it lowers the cost and risk. So essentially, you can actually get something that is already ready for you to start developing and iterate. So that is actually a great advantage of using a Toradex hardware for immediate prototyping, essentially. We also offer a frictionless migration. You know, once you actually have validated your applications in prototype, you can move to production very quickly with our hardware. Since recently as well, SYSGO has a BSP, a board support package for the i.MX 95. So you can actually just get started very quickly. So yeah, over to you, Stefan, if you want to actually tell us a bit more about SYSGO PikeOS and use cases specifically.
Yeah, hello from my side. So when we look at possible use cases, you can use PikeOS on the i.MX 95 board for situations where you need safety or security. And you can use it to combine safe, critical, and non-critical applications on one board. For example, in a mission computer or in a flight control, you can combine it on an edge system to add some, for example, AI image recognition or something. And this can execute without interfering the critical parts. And that's also true for security. You also can build up a system that you can isolate sensitive data and functionality from non-critical parts. Yeah, coming to SYSGO, our company was founded in 1991. We are an operating system vendor for embedded systems and real-time systems. We started in the avionics area and also work in all the other major industries. Our main product is PikeOS, which is a certified real-time operating system with a Type 1 hypervisor. And we also have a Linux distribution, Linux, for embedded Linux. And we are a member of the Thales group. Yeah, when we come to our main product, PikeOS, this is an operating system with hard real-time capabilities and has a Type 1 hypervisor. It is built on top of a separation kernel to provide these, we call it partitions, or you can say virtual machines for applications and guest operating systems. So we can separate the different applications and separate partitions here. You have to provide the resources and you can define the schedule behavior, and PikeOS guarantees that these boundaries are never violated. Within these partitions, you can run a complete operating system like Linux or Android, depending on the architecture, also Windows. We have support for runtime environments like POSIX or ARINC 653. And of course, PikeOS also provides an API that you can use to write drivers or small applications. With this approach, you can build mixed critical systems. You can use this, for example, for rapid prototyping to develop your applications in Linux. And then you can distribute functionality, put it from the Linux partition into another partition, and then certify it later if needed. And then you can get benefit of the safety and security features. We support all major architectures, and we have multi-core support. For the certification for safety, we have certificates for, or have done projects for all kinds of industries with all kinds of standards. For example, in avionics, we have projects where PikeOS was certified to DO-178C DAL A. And for security, we have a common criteria, EAL 5+ certification. And we provide certification kits to customers when you want to do certification projects, that you get special support from us and a lot of documents you need. We will talk about that later. For multi-core support, PikeOS is AMC 20193 compliant. And therefore, we have ways to control the caches, the memory accesses with DMA, the interrupt handling in the system. And of course, you can control the behavior of the scheduler and the interpartition communication. And all of this is certified to the highest security and safety levels. For the multi-core management, we have scheduling possibility that you can assign partitions to special CPU cores, and you can define a time schedule. We call it time partitioning, to define which partition is active in which point of time on which processor. So you have really deterministic behavior in the system. And also a very abstract view on the system, that it's easier to certify to see what the processes are actually running at that point in time. You can use PikeOS for symmetric multiprocessing and asymmetric multiprocessing. So depending on your requirements, what you want to achieve, you can use both approaches. And we provide also some certifiable components. You can use like a network stack or file system. For the certification kits, we have a modular approach. That means for all our components with PikeOS, we provide certification artifacts, for example, for the separation kernel and for the hypervisor and for the APIs. And in a certification project, you can reuse these documents directly. So customers can then write their critical applications, for example, in ARINC 653, and just have to certify their code. And maybe depending on the hardware, the platform support package describing the boards. If you have an own board with own IP, you will not give out to someone. You can provide the platform support package for that board. And of course, this has to be certified then as well. And what you see also in this picture here, if you have other partitions next to certified partitions, this doesn't break the certification. So it's independent, they are strictly isolated. And this is ensured that critical applications do not get disturbed by other stuff which is going on in other partitions. When you want to implement small applications on PikeOS without a full operating system, of course, if you use Linux, then you can develop with everything what Linux is capable of. But if you want to do just a small application, we provide support for C and C++. For the POSIX API runtime environment, we are currently preparing, and we call it next generation, with improved scheduling capabilities. And there we will have a certifiable standard template library for C++. And you can use the Rust language to develop applications. Of course, we have an IDE to support you with this. It's called CODEO. It's based on Eclipse. And there we have guided configuration. You can use the debugging framework of Eclipse. You can get runtime information of the target running. So see what partitions are active, which resource consumption is used by which partition. You can get timing analysis of the applications running there. And during development, you can deploy applications in a partition and run them there. Okay, then we want to present a small demonstration of our tools. Here we see CODEO, our IDE. I am here preparing a system on the i.MX 95 board. I start with an integration project. This is where we select the BSP use. We have some demos. I select a small one with one PikeOS native application to use the API of the separation kernel. And I clone this project here. So you see now the basic configuration. To execute something in the PikeOS partition, of course, we need an application. So that's here. I'm cloning now a PikeOS application project. I use a simple hello application just to execute something. And you will see this is a very simple application which just prints a startup message in an endless loop. Then it sleeps for some seconds. So I change the code here that we see that it's really, or that we're executing the program what we are currently developing here. So I compile this with our toolchain and install it in the pool. We use this pool as an exchange area that you don't need to deal with a complete path to applications or to binaries and libraries. So I install part in the pool. I created the boot image, put it on a TFTP server, and now start the i.MX 95 board. You see the serial output here of U-boot. Then we see the boot messages of PikeOS and output of Hello World partition, which is executing there. Here I create a connection from CODEO to the target, to our tools. So when I connect, we can see which partitions are running. I can start and stop partitions. So I can stop here the PikeOS partition and can restart it. And then we see the startup message again, and then it's running normally. Okay, next what we see now is I will add another partition, which we will use a Linux system. So I add a Linux partition and the process with all the configuration. I have to adjust the network settings. And yeah, now we have a unique partition identifier, and I have to assign it to the correct partition and the communication channels to that partition. And I give it network access because I want to have a small HTTP server in the Linux partition. And now, of course, we need a Linux, what we can execute in there. So I use our Linux distribution and create a project to build the Linux kernel. Yeah, we use networking. And you see, I have to select which BSP for Linux to use. I, of course, use one to execute in a PikeOS partition. So you can run an Linux native on hardware, of course. So I now create the project. Next, we will see some feature configuration. We have some abstraction layer above the kernel configuration where we can configure, for example, file system and kernel settings in one place here. So I have set the IP addresses already, and I add a web server and an SSH server that way I can connect via network to that board. I did not compile the kernel here. I have pre-compiled it because compiling of Linux kernel takes some minutes. So this is already pre-compiled here. So I regenerate the boot image of the PikeOS integration project and install it on a TFTP server. And then I restart the i.MX 95 board. We see the output here. So you see the boot image was larger than before. We see some output of the Linux kernel here already. And I put it back in the lower right part. You see the serial output of the board. Now I have another window in the terminal window. I log in with SSH to the Linux partition and can also load the web page from a web browser on my development laptop. And the other partition is still running next to it and print to the serial console.
Yeah, that was great. Thanks so much. So I was impressed how easy you made it look like. Yeah, I guess that is a bit harder when it's the first time you do it, but with your experience, actually, it just looked like very seamless.
Yeah.
All right.
And we have some good tutorials.
Yeah, I can imagine, and I'm sure that you are at hand to help customers actually to things. So, all right. So now that we saw the software side of things, let's actually take a closer look at the hardware. So the i.MX 95 is a new chip from NXP that we actually see as a normal evolution to the i.MX 8 platform. So we have actually a broad portfolio of i.MX 8 and plus products, and we see that customers are very interested in the 95 as the normal evolution. And it's a great fit for next generation applications like aerospace, avionics, defense, and industrial applications. So this chip features up to 6 ARM Cortex-A55 cores, in addition to 2 microcontrollers, which are actually in an independent safety domain. So these Cortex M7 and Cortex M33 CPUs can actually enable real-time processing and very high power efficiency. So that's why it makes a lot of sense for companies like SYSGO actually to focus on the 95 because of this heterogeneous infrastructure. It also has a very rich set of high-speed interfaces like this 10 gigabit Ethernet and automotive Ethernet. So it's also a very great product for automotive customers. The i.MX 95 family integrates secure enclave as well. So it's basically streamlining this critical function like a secure boot, cryptography, trust provisioning, and also the runtime attestation. It's essentially simplifying the whole cybersecurity compliance. It makes it very easy actually to comply with regulations such as the upcoming CRA, the Cyber Resilience Act in Europe. So it also has a very powerful Mali GPU, which is actually part of the real-time domain. So you can have critical information in safety or like real-time applications, like leveraging the GPU. And finally, when it comes to display, multimedia, and also machine vision capabilities, this product comes with built-in Neutron NPU. So you can run computer vision applications with multiple cameras. and an integrated ISP, so image signal processor for advanced vision tuning. So essentially, it is a very well-run up product, and that's why we're getting a lot of interest from customers. And actually, a testament to that is the fact that we have 3 families already supporting the i.MX 95. So from the very top, you can see that since 2024, we have an evaluation kit. So our Virgin evaluation kit is mainly for, obviously, evaluation purposes, so it's not a production-ready product, but has been enabling a lot of customers just to test and to prototype. It comes with a SOM and also a carrier board, and it will continue to be available for some time, but we'll basically phase it out at the end of this year. Recommend customers start actually testing directly on the production-ready products, which are the Smart i.MX 95, which is already available in sample stage, the Virgin i.MX 95, which is, I guess, the small factor family is our wider range compatibility family. And finally, the latest addition is the Aquila. So the Aquila i.MX 95 for any high performance applications. It has a very extensive interface set with 400-pin connector. So essentially, you have a very wide choice if you really want to actually develop with this particular chip. So I will not really dwell on the specifications. That's a lot of data in there, but I just wanted to show the comparison of the different form factors so you can see actually how they compare with each other. Maybe something to point out is that the Virgin has a 15 by 15 chip. So it is actually smaller than the other ones. The Aquila Smart, they have this 19 by 19, so it's a bit bigger. So it's actually a very nice fit for applications that require small size, which probably is the case in some of the projects that you're working on. All right, so let's jump on the software side of things on the Toradex front. So obviously, we are a hardware manufacturer, so Toradex is mainly focused on the hardware, but we also provide a production-ready operating system, which is Torizon. So it is a free open source operating system, and also on top of it offers an IoT platform for industrial use cases. So it comes with automotive-grade update client to allow safe software updates, over-the-air updates. Security is a very focus for Torizon. So we enable customers to actually do very frequent updates using our platform. And essentially, it's built with the Yocto project. So we utilize Docker for containerization of the applications. So it is actually quite interesting to use Docker container to isolate the application from the operating system and maybe from other containers or application. That is actually quite handy as well when it comes to certification. Because you can actually isolate the different applications within the operating system. All right, so just to wrap up, to put it all together, what we discussed. So first of all, the reason why we are collaborating together with SYSGO is because we want to ensure that safety and security is offered to our customers by design. So we are combining a very secure and solid Linux solution together with a real-time operating system, both for non-critical and for critical applications. And it's all on the same hardware. The ability of running different operating systems in different partitions and different event cores. So you can actually get to that level, controlling the interfaces at the level of the operating system and the partitions, I think is actually very valuable. Also, to reduce the swap and the cost. So essentially, smaller in size, lighter in weight, and they also consume less power. And this is really, really relevant, I know, in aerospace, defense, and drone, tactical gear, these kind of applications. So the physical constraints and the power consumption are really, really important. Also, trusted connectivity, the future-proof flexibility, and eventually allowing you to have a fast certification and deployment path. So that's the reason why we think that the solution of PikeOS together with Toradex hardware makes a lot of sense for your projects. So with that, I think we can actually jump into the Q&A. So I will just quickly open the questions to see actually what questions we got. I'll start with this one is, so how easy is it to migrate existing applications to this architecture without starting from scratch? So that would be the first question. So I guess maybe I can take from my side. I think migrating is very doable. So it is easy in the sense that actually we provide, at least from the Toradex side, we provide a lot of resources, both on the developer side and also from our sales team if you actually need any support. So it allows you not to rewrite everything. So I think it is actually quite possible to migrate your application to our platform, but it all depends actually where you're coming from. Actually, so I think here we just probably need to go a bit deeper into what is the where you're coming from, what are you migrating from. But I think from our side it's relatively straightforward.
Yeah, from PikeOS side, from our side, but we are very flexible. So as we have seen, we can use asymmetric multiprocessing or symmetric multiprocessing. So you can, in the easiest way, have some core executing the legacy code and the other cores running other applications. You can put it, if it's Linux-based or POSIX or ARINC 653, you can easily put it in a partition and run it directly, or you have some porting effort to migrate it to the PikeOS API. So it depends on, as always, on the requirements, but it's very doable, yeah.
Good. There's another question, a very specific question. I think this is good. So should I need to assign dedicated hardware resource for Linux and PikeOS? For example, number of CPU core, dedicated memory. So do you actually need to dedicate the specific hardware resource for each of the partitions?
Yes, you have to, because otherwise we cannot guarantee for the worst case execution times and for the safety requirements. So we have a static configuration in PikeOS, and you have to do the configuration before the system is built, and then it will never change at runtime.
All right, good answer. Let me actually have another look at the questions. Yeah, so how does PikeOS ensure safe separation between critical and non-critical applications on the i.MX 95 SOM?
Mm-hmm. Yeah, we have this time partitioning, we say it, so we can define which partitions are allowed to execute on CPU cores in which point of time. And if you assign the critical application some time partition here, then PikeOS really guarantees that it's certified that only this partition can execute in this point in time. So you have to define the schedule, and then it is guaranteed that this will not be broken. So there's no interference. And also for the memory resources, we have said before, we have a static configuration of all the resources, and it will not change at runtime.
All right, good. So I think we have a follow-up question from a couple of questions before. So what if PikeOS is using a few GPIOs from bank one and a few being used by Linux from the same bank? How can you actually handle the scenario where they're using the same GPIO?
If you want to separate this, then you would need a separate driver controlling the hardware and having a virtual interface with only the assigned pins to the different partitions. But then you will need an additional step in between.
Mm-hmm. Got it. And what is the mechanism to communicate between PikeOS and Linux? Is there actually any channel between them?
Well, it depends. If you use para-virtualization, that means the Linux kernel knows that it's executing on PikeOS, then you can use a trap interface. And if you use hardware virtualization, then we have some specific device drivers. So you have so Linux will call some device and communicate with this.
All right. And actually, yeah, another follow-up question on that. Can we schedule any activity from Linux which is going to run finally on PikeOS? I guess can you actually switch activities from Linux to PikeOS?
If I understand it correctly, you want to have some Linux application and then you want to execute it on PikeOS directly? Is it?
The way I understand it is that maybe you schedule some specific application, maybe some action on Linux, and then you want to actually transition and migrate it to PikeOS. Is that even possible?
Yes, you have to. Yeah, you have to migrate to the PikeOS API then, or POSIX. You can use POSIX, for example. So to develop the Linux application in POSIX, and we have a POSIX API. So you have to mostly recompile. Of course, some small adaptations would be necessary, but that would be the easiest way.
Got it. Yeah, I think. I mean, I have my own question about this. So what if you actually want to make changes on the go, right? So basically, you design your infrastructure statically, right? And then you install it. But if you actually want to actually make changes once the product is on the market, is that possible, or is it basically just setting on and static for the life of the product?
Well, we have over-the-air updates possibilities, but that depends on the project. So what do you want to update and how? Essentially, you have to. Yeah. You have to exchange the boot image, let's at least, and reboot. But we have ways to do this.
Good. All right. So another question is, all right. So is the Toradex board, the i.MX 95? So it has the hardware acceleration elements besides the CPU, NPU. So how is PikeOS planning to support hardware acceleration? Is that supported by PikeOS?
Yeah, I would say from operating system point of view, this is just some memory, so some device, and which can be mapped to a partition. So the application is responsible for this, but it can be used. It would be more complicated if you want to virtualize it. Then, as I said, we would need some driver.
Got it. Okay. And what is the level of POSIX support in the PikeOS for Toradex? So in particular, what about pthread for multi-core applications?
We provide the PSE 5.2 profile for POSIX. We have pthreads, but we don't have users. Yeah, file system is supported, and yeah.
All right. So many questions, actually. I'm just trying to digest all of them. Yeah, this one, I think it is, taking a step back, looking at certification. So can mixed criticality designs like the one that we just described simplify compliance, or do they make audits more complex?
It can simplify because it is so strictly separated that you can leave the uncritical parts outside of the certification process.
But I guess that you need to be very thorough for the certification, because so it adds a bit of additional work, but it makes the whole process of certification easier.
Yes, you have to certify the configuration, this part of the certification project, and then if you have done it correctly, then you don't have any interference, and then you can just certify the critical parts, and the other criticality levels can leave them out.
All right, good. So I think we went through all the questions. There were a couple of questions that were already asked and answered, so I'll skip them. But I would just like to thank you, Stefan, for your time, and the audience for your attention. I personally learned a lot, so hopefully you did as well. And very much looking forward to seeing these projects that you guys are working on, and hopefully we can support you with our hardware and also with PikeOS. So thank you, Stefan. Thank you so much.
Thank you.
Bye-bye. Cheers. Bye.
Goodbye.